I'm going to be demonstrating a series of problems that involve using combinations to count groups of things pulled out of other groups. Now, I'm assuming that everyone is comfortable with the idea, for example, if I have 6 people and I create a committee of 3 people, the order doesn't matter. That's just a combination of 6 taken 3 at a time. So if you have questions about that, send me an email. I can put together some other video, but I'm assuming we have a basic understanding of combinations before we launch into these problems. To take a look at this example, let's say the Campbell County Math Department, or maybe a math department a little bit bigger than ours, has 5 Algebra 1 teachers, 4 Algebra 2 teachers, 6 teachers who teach geometry. And I want to put together some kind of math advisory committee that has, actually let's make this a 4-person committee since I've got 2 and 2 here. A 4-person committee made up of 2 Algebra 1 and 2 Algebra 2 teachers, so maybe an algebra advisory committee. The key here, and the word is not here yet, the key to doing these problems is to try to break the problem down into smaller, more manageable problems. Okay? In particular, look to see if you can apply the use of the word and or the word or to break the problem into pieces. Notice here what I'm trying to do. I'm trying to get a committee of 2 Algebra 1 teachers and 2 Algebra 2 teachers. In other words, I can break this up into 2 separate parts, and as we've discussed, that and usually suggests that I'm going to be multiplying. So I really have 2 groups. I have an Algebra 1 group, and I have the group of Algebra 2 teachers. Okay? This is the fundamental counting principle. This is just like if I had 4 ways I can choose a pair of pants and 5 different ways I can choose shirts. For each of those 4 pairs of pants, I could have 5 shirts branching off of it. Same kind of thing here. If I can find my different numbers of groups of Algebra 1 teachers, I can pair each of those with however many groups of Algebra 2 teachers I have. So while it kind of looks like I'm creating an ordering here, these are really 2 distinct separate categories. I'm just finding the total of numbers I can get Algebra 1 teachers, total number of ways I can get Algebra 2 teachers, and those are going to be multiplied together. Okay, the word and suggests that. And so now this is 2 simple problems. How many ways can I choose 2 Algebra 1 teachers from a group of 5? Well, that's simple. Order doesn't matter. This is a committee. That's just a combination of 5 taken 2 at a time. That's the Algebra 1 teachers. Okay? How many ways can I select the Algebra 2 teachers? Well, I have 4 Algebra 2 teachers, and I want to take 2 of them out. Okay? Just counting only the ways that I can select those Algebra 2 teachers. So that's 4 taken 2 at a time. And that's how I select my Algebra 2 teachers. You can finish this. 5 taken 2 at a time, you could go through the combination there. In this case, 5 taken 2 at a time is going to be equal to 10 different groupings of pairs of Algebra 1 teachers. A combination of 4 taken 2 at a time, that's 6. So there are 10 different ways that I can choose my Algebra 1 teachers and multiply. There's 6 different ways that I can pick those groups of Algebra 2 teachers. Again, technically what's really happening here is if I was going to create a tree diagram, I could have 10 different groupings of Algebra 1 teachers listed, and then branching off of each of those 10 Algebra 1 teachers, I could have 6 different groupings of Algebra 2 teachers. And so 10 groupings of 6, of course, would be 60 different sets of possible groups I could pick that meet these requirements. So again, from a setup standpoint, that's really all you need. Final answer here, of course, is going to be that there are 60 different committees that I can create. So not too tough of a problem if you can break it down into small pieces and look for that use of the word and.